डे 4 की इस क्लास में आपका स्वागत है। पार्ट सेकेंड के मोशनल प्लेन हम स्टडी कर रहे हैं, जिसमें वेलोसिटी एंड एक्सलेशन इन द डायरेक्शन ऑफ रेडियस वेक्टर एंड परपेंडिकुलर रेडियस वेक्टर हम ऑलरेडी फाइंड कर चुके हैं, फॉर्मूला डिराइव कर चुके हैं उनके लिए, जो रेडियल वेलोसिटी, ट्रांसवर्स वेलोसिटी, रेडियल एक्सलेशन एंड ट्रांसवर्स एक्सलेशन। अब हम आज टू डायमेंशनल कर्व में के अलोंग पार्टिकल जब गति कर रहा होता है तो टेंजेंट के अलोंग और टेंजेंट के परपेंडिकुलर वेलोसिटी और एक्सलेशन की स्टडी करेंगे। आप जानते हैं कि वेलोसिटी हमेशा टेंजेंट के अलोंग होता है, इसलिए नॉर्मल कंपोनेंट वेलोसिटी का 0 होगा। सो in the present lesson, we consider the problem in which particle is forced to move in definite curvature. In such type of cases, the acceleration are usually often measured along the tangent and normal to the curve. So acceleration along tangent is tangential known to tangential acceleration, and acceleration along normal is known to normal acceleration. Now, the tangential and normal acceleration. Suppose a particle is moving in a plane curve. Now, we want to find components of its acceleration along the tangent and normal to the curve at any instant. Suppose A is fixed point, this one. A is fixed point on the curve, and this is curve. And let its position at time t and t plus delta t. At time t is, suppose it is at p, and at time t plus delta t particle is at u, where AP is r length is s and PQ is delta s. And we know that velocity component along tangent is v. This is the total velocity. Suppose this is v, and along normal velocity is 0. So resultant velocity along tangent, and this v is rate of change of displacement, and displacement in time delta t is delta s from p to q, and so this velocity v will be ds dt. This velocity v will be ds dt, and it is denoted by s dot. So v is s dot, where if s is length of r if. Now let the tangent pt at p and qt dash at q. There are two tangents, pt at p and qt dash at q. Make angle psi, this is psi, and second qt dash make angle psi plus delta psi with x axis. Therefore, the angle between tangents PT and QT dash will be delta psi. Angle between these two tangents will be delta psi. So now change of velocity along at the tangent at P in time delta t. Change of velocity along the tangent at P in time delta t is known to acceleration, and which will be velocity at Q along tangent at P. This is velocity at P along tangent, and now this direction is at Q along tangent PT. So velocity at Q along PT, velocity is a component of this velocity v plus delta v at Q along tangent. Here this angle is psi, so this is delta psi. This angle is delta psi. So, and here you know the normal velocity at Q is 0. This is 0. So velocity at Q along PT is component of v plus delta of v in this direction. So this will be v plus delta v and component along PT is cos of angle between these two directions. This is delta psi. Minus now velocity at P along PT is V. So this will be V. So see here, this is V plus delta V cos delta psi minus P, and then Q tends to P, then Q tends to P, then delta psi tends to 0. So we want to velocity at P, it means delta psi is 0. Then in this case cos of delta psi will be 1. So cos delta psi tends to 1. Cos delta psi is 1. So it means this is 1, and we cancel out. So delta t. Final result is delta. This is delta v. Or you can see that cos delta psi is, why cos delta psi is 1? On expanding this cos delta psi, we get this one. So this delta psi square is very small, so can be negligible, and higher order terms also. So the change of velocity along the tangent at p in time delta t is v is delta v. Now the change of velocity along the normal line also we want to find. This we will find later. Now by definition of acceleration along the tangent at p is rate of change of velocity along the tangent at p in time delta t, and rate शब्द हटा देने पर डिवाइड बाई डेल्टा टी, and then q tends to p, it means delta t also tends to 0. You see here at q this is t plus delta t, and at p is t, so delta t tends to 0 and q tends to p. So now change of velocity along the tangent at p in time delta t, this is delta v. So we can put here this delta v over delta t, and this is dv dt, or dt v is dsd as tau, so d2 as dt2. So we find that this is tangential acceleration. This is tangential acceleration. Tangential acceleration. Also, this term is dv dt, and dv dt can be written as dv ds multiplied by ds dt. So, but ds dt is v. Ds dt is v. So this is v dv ds. This will be v dv ds. So dv dt is v dv ds. Thus, component of acceleration along the tangent, this is known to tangential acceleration, is this one, dv dt from here, v2 as dt from here, or v dv ds. So this is tangential acceleration. If we want result in velocity and time, then we use this is dv dt. If we want result in s and t, means arc length or distance and time, then this will be d2 s dt2. Or we want result in velocity and distance, so we use this v dv ds for tangential acceleration. In the same manner, acceleration along the normal at p will change of velocity along the normal, change of velocity at normal. This will be velocity component at q in the direction of perpendicular to pt. This is direction perpendicular to pt. तो q पर इस डायरेक्शन में हमें इसका कंपोनेंट लेंगे. This will be this angle is v plus delta v, component of v plus delta v, component of 0 will be in this direction 0, and component of v plus delta v in this direction is angle between this v plus delta v and normal at q along perpendicular to p. So this will be 90 times this angle is 91, right? So component of v plus delta v in this direction will be v will be v plus delta v multiplied by cos of angle between these two. This is 90 cos of this is 90 plus delta psi. So this is minus sine delta psi. You know that this is minus delta psi, sine delta psi. So b plus delta b. This is not plus 0. Component of 0 in this direction is 0. So this minus velocity in this direction at t, this is also 0. So here you know sine delta psi, this is minus sine delta psi, and sine delta psi, when delta psi tends to 0, then sine delta psi tends to delta psi. So we can put this cos of 90 plus delta psi at this cos of 90 plus delta psi minus delta psi. So here this is b plus delta b. This will be b plus delta b and multiply by, मैं बता रहा था आपको, cos of 90 plus delta psi है, तो माइनस ऑफ साइन डेल्टा psi होगा, एंड डेल्टा psi इज डेल्टा psi. ये मैंने आपको बताया. तो और perpendicular component here at p, perpendicular to p is 0, so this is 0. This is change in velocity along perpendicular to pt in tan delta t. So this gives us b plus b delta psi, right? First term is b, second term is delta psi, and delta v delta psi is negative delta. So this is b delta psi over delta t, and this b delta psi delta t, limit delta t tends to 0. This is d psi dt, d psi ds, and d psi dt is multiplied by ds and divide by ds and multiply by ds. This will be d psi ds ds. But you know that this ds ds is rho 1 over rho. D psi ds is 1 over rho. You know rho is ds difference. So this is rho, radius of the curvature. So and also ds dt is v. So v multiplied by v is v square. So ultimately acceleration along the normal at p is v square over rho. This is known to normal acceleration. So normal acceleration is v square rho. Normal acceleration v square rho. And then there are two accelerations along tangent. This is tangential acceleration along normal, which will be normal acceleration. So resultant acceleration will be in some direction at p. Suppose this is our torque APQ, this is P, this is tangent. Suppose this is normal. So tangential acceleration, suppose this is resultant acceleration, that is not resultant acceleration. This point is P. This point is P. So This is the resultant suppose this is resultant axis. That is not resultant axis. And this next angle with the tangents. Suppose this is angle with the tangent is alpha. Then tan alpha is normal component over tangential component. So normal component is v square over rho. This is normal component, and d2 as dt2 is tangential component. So direction is given by this formula, and resultant acceleration is square root of tangential acceleration square plus normal acceleration square, or in this is resultant acceleration. In case of circle, curve is circle, suppose then radius of circle is a, then s is a theta, so and rho is a, we know already this one, so v is a theta rho and s double dot is a theta dot. So normal acceleration will be v square over rho is this a theta dot square plus the sin square. Now example, यहाँ हमने सीखा this is tangential acceleration and this is normal acceleration, and this is the direction of normal acceleration and resultant acceleration. अब example 1, a point distances the cycloid, suppose this is the rho, with uniform speed, find its acceleration. Acceleration is square root of tangential acceleration square plus normal acceleration square. So we want to find tangential acceleration and normal acceleration first. But curve is s equals to 4a sin psi, and velocity is, we know, velocity is s dot, which is constant, uniform speed v. This is s dot is constant, which is given here. Constant. So this is constant, and s double dot will be 0. Now ds dψ from equation 1 is differentiating with respect to psi. We get 4a cos psi right hand side, and this is rho. It means rho is 4a cos psi. Therefore resultant acceleration square equals to tangential acceleration square plus this is normal acceleration square. Here s double dot is 0, and this is v square. This is v square over rho, and rho is 4a cos psi. Can be written in for s like that. So velocity is v square over root 16 a square minus s. Then now example 2, a particle describes a plane curve if the tangential and normal accelerations are each constant. Here tangential acceleration is constant, yes, this is d2 as dt2 is constant, suppose mu, and normal acceleration which is v square over rho, हमारे फॉर्मूले से is constant से lambda. Constant is constant throughout the motion. So now we have to prove the angle psi through which the direction of motion turns in time t is given by this. We want to equate between psi and t. So integrating 1, ds dt is mu t plus constant integration, and from 2 v is ds dt square multiplied by rho is 1 over rho is ds psi ds is lambda, and this is ds dt d psi dt clearly equals to lambda, but ds dt is mu t plus c1, so this ds dt can be written in the form mu t plus c1, and this gives This is the differential equation of order first in psi and t, and on separation of parameter d psi dt, and on integrating left side is psi and integration of right hand side is this one. But initially let t is 0 and psi is 0, then c2 is minus lambda upon rho of c1. So put this value of c2 in this one here, and finally we get lambda or mu equals multiplied by lambda 1 plus mu over c1t, or this is again a constant, say a log of 1 plus, and this is say b constant multiplied by t. So psi is in this form a log of 1 plus pt. Psi is. In example 3, a curve is described by a particle having a constant acceleration. Here acceleration is constant, means resultant acceleration is constant in a direction inclined at a constant angle. मान लीजिए m डायरेक्शन में इसका रिजल्टेंट एक्सलेशन है अल्फा, आल्सो कांस्टेंट. Direction of resultant acceleration is pm. Angle p alpha with pt is alpha, which is constant. So that the curve is, and we want to find the path. Here, by this formula, direction formula, tan alpha is normal acceleration over tangential acceleration. Tan alpha is normal acceleration over tangential acceleration, and normal acceleration is v square over rho, you know, and tangential acceleration is v dvds. So this is v dvds equals to v square over rho photo alpha on solving transposition, and resultant is square root of, this is constant here, constant acceleration. So say k is constant. So resultant acceleration is square root of tangential square plus normal acceleration square equals to constant. But v dvds we can put this one from 1. In place of v dvds we can use v square over rho photo square on solving. V square over rho is equal to alpha, and this gives v square equals to 0 sin alpha. But from 1, question number 1, see b dv over v square, dv over b equals to separation of parameter. We can write this dv over b equals to total b psi as rho as d psi, and on integrating we get v is c e power 4 of alpha. So from 2 and 3 put value of v, we get k rho sin psi alpha v square value, and c square squaring both sides and put value of v square from 2, we get this one. And on solving, this is k sin alpha ds d psi equals to c square e to power e raised to power 2 sin 4 of alpha. Here this is rho, value of rho. So on this is differential equation of order first, and on separating parameters d psi equals to ds equals to c square over k sin alpha e raised to power 2 sin 4 of alpha, and multiplied by d psi multiplied by this d psi. So on integrating, this is s, this is constant e power 2 psi cot alpha with integrated with respect to psi over 2, this is 2 cot of alpha, this is cot of alpha plus integration constant b. So as is this is new constant, suppose a e raised to the power this multiplied psi by constant 2 cot alpha is say m plus b. This is the intrinsic equation of equiangular spire. So path is equiangular spire. In this case, when acceleration is constant, which makes angle constant alpha with tangent, then path of such particle is equiangular spire. Okay? तो हमने आज टेंजेंशियल और नॉर्मल एक्सलेशन और उनसे संबंधित प्रॉब्लम स्टडी की. Tangential acceleration is in three terms: dvdt, v2 as dt2 or v dds, and normal acceleration is v square over rho, and direction of resultant of acceleration is square root of tangential acceleration plus normal square, and direction is tan alpha given by normal acceleration over tangential acceleration. ये आज हमारा और इसके साथ उदाहरण देते हुए हमने स्टडी